Okay, recording has started. Now let's go to Unit 4. So Unit 4 contains 2D random variables. We saw 1D random variables in Unit 3. Just seeing 2D random variables here. We'll see that for discrete and continuous, then joint probability, marginal conditional probability, and then independence of random variables. We'll just see how two are together and then how independent they can be. And then after that, we'll see covariance, correlation, and then regression. So let's start first. What is a 2D random variable? So, oh wait. Oh, new message anapitiya. Nice. Starting unit 4. Okay. So, what is a 2D random variable? 1D random variable will have on, like for example, this graph is a 1D random variable. 2D random variable, imagine there is two things, x and then y, two variables in play. So, x will give you something, y will give you something, and then there is x and y. So, take x as, okay, assume you are writing an exam. Take x as your hall number. So it can be anything, just it's a random variable. And take y as your paper set. So both are random variables here. You can't predict what will be your hall number nor your paper set. And both can come together. Your hall number can be one, paper set can be one, hall can be one, paper set can be two, like that. It's just like a, you just do, oh wait, yeah, just like a graph. We have x over here, and then y, and then you just see all variables of x will be here, all y will be here. How x and y come together. So this thing will give you the entire gist. So here is x is one random variable, and this is y. These are all discrete random variables. So we have like a random variables defined as x comma y. That is, instead of defining as just x, we define it as x comma y. X comma y is a 2D random variable with varying values of x and varying values of y. So now let's take joint probability. In this case, it's discrete. So guys, here, I don't think continuous is there in the notes that's given, but whenever there's continuous instead of discrete, just replace wherever a summation is there with integration. That's it. So we have some formula for discrete and there's one summation symbol. If you want to turn that into continuous, just make it integral. So very simple. So here f of x1 and y1, what does that mean? So probability that x is equal to x1 and y equal to y1, not just one. We have to figure out both. So let's just take this. So f of x comma y1 here. So the probability that x1 will be one value and y1 will be one value. So it's just given by some equation or something. Equation if it's a continuous, uh, like graph if it's non-continuous, discrete. So just take, yeah, this one. So here y values are y1, y2, y3 till ym. This is in discrete case. X values are x1 to xn. So this entire grid, this is the f of x here function. So for each x1 equal to x and y1 equal to something, it will give you the value here. So that is the joint probability. And next, let's see marginal probability. So we have joint probability. We are seeing how x and y are there in 2D. So given we have the joint probability, how do we find the value of x? So we have the function for f of x, xy. That is the joint probability. How do we find the function for f of x? This thing is here. So f of x is x1 to xn. This is y1 to ym. So we have this grid square. We have square over here. How do we find this specific thing? So here, so P11 is nothing but x1 into y1, multiplication of this. So you want to see that, you want to get x over here, just add all of these. Again, add all of these. Here is x1 into y1, it's x1 into y2, it's x1 into y3. You want to get x1, just sum up this thing, just sum up everything. So x1 into y1 plus y2 plus y3, everything will give you this. The probability of x1, for example, take this is 0.5 over here. Is, yeah. So take x1 is 0.5. Here x1 this probability is split into for y1, y2, y3, and ym. So we all x1 is 0.5. So what's the p11 means? What is the probability that x1 is this value and then y1 is another value? So x1 equal to this and then y1 equal to this. So we already know probability of x1 is 0.5. So probability of x1 to x1, y2, x1, y3, adding up all this will not cross 0.5. So for us to get the joint probability, marginal probability, that is f of x, we have p of x1 equal to xi. So we just sum up xi and yj. I is constant here. Y is the only thing that will be variable. So keep x as variable and add all y. And we have set of xi and pi. So pi here means here px or py, whatever you want to define it as. So this will give you that of x, the marginal probability. This will give you marginal probability of y. So marginal probability is done. Yeah, that's what they're saying here. So marginal probability as a mass function of x. So here what they're exactly doing here is, like I said, they're just adding p1 plus p2. So here if you see that x thing, that's I constant. Similarly for y. Just see the first value is vary, second value is constant. So the marginal distribution yi p dot j, that will give you that. So conditional probability. We have seen Bayes theorem. P of x given y is nothing but P of, let's go here. Yeah, P of x given y is nothing but P of x into P of y by P of y. So we just take it in this sense, random variable x thing. So P of x equal to xi. That is the probability that the random variable x will be xi. The probability that the random variable y will be yj. This is the formula. So this is the conditional probability formula here. It's nothing but, like we saw earlier, P of y equal to yj. That is this thing over here is the marginal probability. And this thing is the grid. Here, Pij is this entire grid. And this thing, P star j. Star j means x will vary, y will remain common. Just this 1 cross n matrix over here. So that's the conditional probability over here. Again, in the case of conditional probability, if P of ij by P of j is equal to P of I, what does it mean? So, regardless of whether it's ij, the value of y, x value remains the same. So that means that a is independent of y, x is independent of y, and y is independent of x. So that means that all this thing P1 to Pm will be same. This thing will be same. This entire grid will have the same value all over in the case of independent probability. Next is the joint CDF or joint cumulative distribution function, however you would like to call it. Yeah. Oh, sorry. Cumulative DF, cumulative distribution function, not conditional. So here we have f of x comma y equal to p of x lesser than some value. So the x is lesser than this xi, y is lesser than yi. So what is the probability here for both cases? So what did we do for the previous thing, that is condition cumulative distribution function for continuous variables? We just integrated from minus infinity to that x value. Here instead of integrating, we're just summing up till that value. So if we just see here, so joint CDF is nothing but here summation symbol from starting till I, where xi lesser than x, that is the term that we want, and yi less than y. So if we just take it from the previous thing we saw, it's exactly the same thing here, except it's two variables here. So for previous cumulative distribution function, we saw that it's integral of minus infinity to a f of x. Horrible handwriting, but okay, f of x. So it's nothing but double integral here. Instead of x, we have x and y. So just integrating both x and y. So here, like I said previously, if you just want to make it continuous, replace with integral. Main thing is you have to link between previous unit and this unit. Both are not different equations. They are essentially the same equation. Instead of one variable, here it's two variables. Hence, two summation symbols come. That's the only difference here. So next thing is covariance. So what is covariance? Covariance essentially means the relationship between two variables. So whether one affects the other, we have x in one side and y in another side. So does the value of x affect y? How is the relationship? That's the thing. So covariance formula is expectation of x minus e of x, y minus e of y. You just take it out of the bracket and calculate. Covariance of x comma y is e of xy minus e of x into e of y. So again, e of xy is nothing but, you see, e of x is integral of x f of x. Here, e of xy is double integration of xy probability of x1 y1. Here, think of replacing the probability of f of x comma y. So it's the same expectation value function. So next, we'll go to correlation. So what is correlation? Correlation means measure of covariance. Let's just take a graph over here. Okay, so let's take rainfall and humidity. Okay, so rainfall is slowly increasing. Humidity is also slowly increasing. So now we have to check whether both are correlated. Correlated means whether increase in x would also mean an increase in y, or a decrease in x would also mean a decrease in y. Important thing to remember is correlation is not necessarily causation. Just because x increases whenever y increases does not mean that x is causing y to increase, nor does it mean that y is causing x to increase. So it does not necessarily have to mean. It can be, but not. For example, they might be due to independent factors that are not related, but they can appear related. So that's important thing to remember. And here correlation can also be positive and negative. For example, when rainfall, this is excess rainfall, temperature can decrease. So x and y will be positive correlation. X and z here will be negative correlation. So we have a correlation coefficient R. So that is the Carl-Pearson's coefficient that will be used here. So in Carl-Pearson's coefficient, R of x comma y That is the correlation coefficient between x and y. That is Rxy. This covariance of x comma y by variance square root of variance of x into square root of variance of y. So square root of variance is nothing but standard deviation like we saw before. So if we just take it as an equation, this is the thing that will come. Before we go, there are some properties of covariance here. So first one, covariance of ax and by is AB covariance of x comma y. What does it mean? Since covariance is expectation value, so E of ax is A E of x. A is an independent variable. Sorry, A is a constant. It does not have a relation to x. So you can just take A and B out. So again, covariance of x plus A and y plus B. So in differentiation calculus, we have seen that constants become zero. Similar to that, no matter what, or just think of it like this. Think of it like this. So a graph that's going like this, x, and this is y. So the covariance won't change if y suddenly becomes plus some offset like this. Y becomes this. So graphically, they're just the same. It's just moved about somewhere in the entire vector space. So we add plus or minus, it does not mean anything. So again, here is a combination of previous. 3 is a combination of 1 and 2. So here it's plus or minus x1 plus x2. So depending on the symbol here, it's x1 plus x2 minus 2. Similar to how we see in sets A and B, probability of A plus probability of B like that. So again, correlation, we saw here positive correlation, negative correlation. Yeah, call Pearson's coefficient. So this is just the formula of call Pearson's coefficient. So next, let's go to regression. So regression is a curve that links two variables. So, okay, let's just take the curve. For example, this is the vector space we have, and the x comma y, these are the variables. We have not variables, distribution of the variables. We have 1, 2, 3. What we're doing is nothing but we are plotting the grid that we saw previously. Remember this? Yeah, this grid P11 to P and M. You're just where did it go? Just plotting that. So in some cases, the two curves that link the variables can become, for example, here the linking thing will be a curve like this. But in some cases, it will be a straight line. The points will be points can be like this. In that case, there can be straight line drawn which can be used to represent those points. This is called a linear regression equation. Linear regression literally means distribution is linear. It follows a pattern. And linear means in the form of a straight line. Ax plus b. Y equal to ax plus b. So we can, since it's a straight line, we can calculate slope, starting variable, everything. So the equation of that here is y minus y dash. So y dash is the variable that the mean of that, and y is the thing that we're taking now. This thing is the slope x minus x dash. So how do we get the formula of this? So r x y, which is the call Pearson coefficient we saw earlier, and sigma of y, sigma of x. This is the standard deviation. So we just calculate this and get this formula over here. So that will give you the slope. And here it's expectation value of xy minus e of x, e of y, then it's e of x square minus e of x the whole square. This is for dy by dx. So if we replace x here and y will go here, here it will become e of x, that's y square minus e of y the whole square. So let's just look at some, for example, here this problem. So let's take the bivariate probability distribution of x, y is given like this. So find the marginal distribution of x and y. So marginal distribution of x, just take here. So x is 0, 1 and 2. We have to find the marginal distribution means probability that, so I'll just take this here. So we have to find the color. So marginal distribution. You have to find for x equal to 0, x equal to 1, and x equal to 2. You have to find for all of those. So for x equal to 0, we just sum it all up. X equal to 0 is nothing but x equal to 0, comma. For x equal to 0, y is 1, 2, 3, 4, 5, 6. We just sum up all this. So 1 by 32 plus 2 by 32 plus 2 by 32 plus 3 by 32. Nothing but, so 8 equal to 8 by 32 equal to nothing but 1 by 4. And x of x equal to 1. Sum up all this 1 by 16, 1 by 16, 1 by 8, 1 by 8, 1 by 8, 1 by 8. Which is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal to 10 by 16. And then this one. So 1 by 32, 1 by 32, 1 by 64, 1 by 64, 2 by 64, it's nothing but 1, 2, 3, 4. 4 by 32, 4 by 32 is nothing but 1 by 8. Just sum up all this. So 1 by 4 is nothing but 4 by 16. 1 by 8 is nothing but 2 by 16. So 4 plus 2 plus 10, we get 1. So just cross check it by adding everything and make sure it becomes 1. This is the marginal distribution. So you have to find that probability x lesser than or equal to 1. So from this table itself, we can find that x lesser than or equal to 1 is nothing but the sum of this. Just add all of this. X is lesser than or equal to 1. And then you find that probability. So next is probability of y lesser than or equal to 3. This one. So just take till y3 and x all values. So next, probability that x is lesser than or equal to 1. Just like this, and y is lesser than or equal to 3. So this thing. So next is probability that x is lesser than or equal to 1, given that y is lesser than or equal to 3. So we saw, how do we do this? Let's go to the previous page, conditional probability. So we calculate pi by pj. So we first find out probability that y is equal to or lesser than or equal to 3, and then do the conditional equation that we did earlier. Similarly, for all of these, it can be found. Actually, for most cases over here, who joined meeting? Somebody joined. Admit. Yeah. So most of these can be found out from this graph itself. So in this case, our x and y independent random variables. So before we mentioned that, so for x and y to be independent random variables, this can't be possible because for x, if x and y are independent random variables, this entire thing will be just one value. Because if x and y are independent, y's value should not change if x is 1 or 2 or 3. So here x is equal to y means y is this, is equal to 3 means this. So joint probability should not change. Here it's changing. So if all of these is not the same value, then x and y are not independent. I think we are done now. They start recording 21:46. Yep, I'll just stop then. Yeah.